So today you have a review on section 7.4 to 7.6 with your test being tomorrow. Let's look at this review packet, just a couple things about it. If you look at question number 1, this section here in this review packet says to change it to exponential form. Remember the two versions, you have exponential form and you have logarithmic form. And what you're given here in number 1 is something in logarithmic form. So if you want to change it to exponential form, your answer would be 4 to the third equals 64, and that's it. You're not calculating, you're just changing the look of it. And that's a skill you're going to need when you're doing your solving. Look at number 4. You have 3 to the 4th equals 81. That's in exponential form. You want to change this to logarithmic form. So the base is 3. So you're going to say log base 3. The answer is 81, and remember the exponent is what it equals. And again, we're just changing the form. We're not doing any calculating. It is a true statement. We're just going to change it to a different true statement. All right, look at number 7. Evaluate the following using the change of base formula. So this is where we're going to go ahead and say, all right, I don't know if I tried to evaluate this, I don't know what that answer would be. So we're going to take our calculator and we're going to type in the log of 20 divided by the log of 5. And when we do that, the log of 20, close off the parentheses, divided by the log of 5 gives us 1.861. So 1.861, and we're going to go to 3 decimal places. Condense these. This is a skill we need when we're solving, so condense. Remember the 3 rules over here on the right. We're going to be using these. The first thing I see is that I have these exponents here that I'm going to bring up, so I actually have the natural log of 16 plus the natural log of x to the third minus the natural log of 2 squared. First thing I'm going to do there. The next thing is I'm going to condense these two. Since they are adding, that means I can condense them into 1 to be the natural log of 16 multiplied by x cubed minus the natural log of 4, because 2 to the second is 4. And then what I see is that since these two are being subtracted, I can go ahead and change this into one single log of 16x to the third divided by 4. Simplify that. That's the natural log of 4x cubed, because 16 divided by 4 is 4. Final answer. The last section on your review packet is solving the equations, and we've learned about 4 different methods. The first one we learned about is if you have 2 things in the equation and on each side of the equal sign we have something in exponential form. If we can equate the exponents or make the bases the same, so something like 5 to the x equals 25, I can make 5 and 25 the same base. So if you can do that, then you're going to use this first method, and you can go back into your notes to figure out what that is. If you can't get the bases the same, you're going to change it to logarithmic form. So something like 3 to the x plus 4 equals 7. I can't get 3 and 7 the same base. Notice they're both in exponential form. They have a base. They have a potential exponent. 7 would have a 1 as an exponent. In that case, then you change it to logarithmic form and use the change of base. Use your notes. Look for that method, method 2. The third method is when you have a single log on each side of the equation. Now it's possible that you might have to condense each side of the equation first, and then you do have a log on each side of the equation. That was the case where you condense them first and then set the expressions equal to each other, solving for x. And then the last method is you have a single log in the equation, or a log only on one side of the equation. So maybe you condense it first if necessary, and then what you did was you changed it to exponential form. So 4 types of solving that you're going to see on the test tomorrow. You need to be able to determine which type is it. What do I do? Can I make the bases the same? If I can't, then I'm going to change it to logarithmic form. Can I get a single log into it made equal to another single log? If you can, great. Look through your notes, methods 1, 2, 3, and 4 to kind of figure this stuff out. Use them as you go through the review packet. Make sure you know what you're doing.